The next visualization or chart kind of thing that we're looking at is called a box plot. Also called a box and whisker plot because the box represents the area, the middle 50%, the area between Q1 and Q3, quartile 1, quartile 3, and the whiskers go out to the other quartiles. Most of the time we'll see them vertical, but sometimes some people draw them horizontal. It's acceptable either way. And so we learned about quartiles and percentiles in Unit 1. So we used that information to draw the box plot. So again, the box is represented by the top of the box is quartile 3. At the bottom of the box is quartile 1. And then we also usually draw the median in here as well, which is quartile 2. So the box represents 50% of the total number or the total thing that we're measuring. So that's kind of interesting to look at, just like when we calculated interquartile range, it told us where the middle 50% were. This also can help us kind of tell if there's a skewed kind of distribution based off of where the median is. Sometimes we'll also draw the mean in there as well, which we will try to do. And then we have the whiskers coming off the top and the bottom that go towards the max and min. Right. We will also sometimes have a outlier symbol here. So if there is an outlier, then we'll plot it with an X or a dot or something. Right. So box plots we can use as for a single variable, but sometimes it's actually even more interesting and fun to use box plots to compare between subsets within a single variable. So if we went back to letter grades that we looked at for the thing, we could say if I plotted the letter grades in a box plot GPA, it'd have to be switched to GPA, and looked at it between males and females, is there a difference between them? In Excel 2013 and earlier, very manual process to set that up. Excel 2016 makes creating these much easier. There's a statistical chart now that we can insert. So that's what we're going to do. So let's go over to Blackboard. I'm going to grab, I'm going to go into Unit 2 on Blackboard and grab, let's use the restaurant stuff from the last video that we did. So I'm going to go ahead and just grab that restaurant data. Remember, we had 300 different restaurants rated as good, very good, and excellent. And then we had meal price and wait time. So if we wanted to create a box plot of meal price, for example, we can select it. I'm going to go back up here just so it goes next to the other plots so we're not going too far away. And we go to insert, and again right here we have insert statistic chart, so just like we did for the histogram, but this time when we pick it, there's box and whisker. Okay, so we bring it down here and let's modify it a little bit. I'm going to get rid of the grid lines. Notice that we have the box, first quartile, median, middle, second quartile, third quartile right here, and then also there's an X right here representing the mean. Notice that it labels it with a 1 here. We could change that label if we want. There are no dots above or below the whisker, so there's no outliers. Now, one thing that's useful is if we go up to quick layout and pick this guy, that's layout number 2, what that does is it puts the values next to each. So you see the median is $25 for the meal price. The average meal price, represented by this X, is 25.89666. So $25.90 basically is the average meal price. The smallest meal price here you're seeing is 10, highest is 48. So this looks like it's pretty consistent, right? It doesn't look like it's too crazy. looks somewhat symmetrical because the boxes in between the third quartile and the median are about the same as between the median and the lower quartile, and then the whiskers are not too skewed either. So let's try the same thing with wait time and see what we get. And then put it back up here close to the other graphs. So again, insert statistics chart, box and whisker, and move it down here. And notice this time, I'm going to go ahead and do the layout so I can see the numbers. This time, notice that we have a bunch of dots up above. So those are considered outliers. Now you can read up on the help menu to figure out how Excel is actually calculating those outliers. All right, so what that tells me is we have a bunch of restaurants that are charging a meal price much larger. And so we're going to be skewed out to the right. So if we just flop this over 90 degrees, right, we'll have a long tail out to the right. And that's also verified by looking at this whisker is longer as well. Which shouldn't really surprise you, right? You'd have the very good and excellent restaurants because they're excellent, they can charge more money. Right? And again, we can see first quartile is 5 minutes, median is 12 minutes, the average is 13.9 minutes, and then 18 minutes for the third quartile. So that's we could add chart titles and all that stuff as well, which probably wouldn't be such a bad idea. So let's go ahead and add a chart element to this. We'll add a chart title above the chart, and this was wait time in minutes, right? In minutes. And this was, what do we call it? Meal price in dollars. So let's get rid of that and add a chart element, chart title above, and this was meal price in US dollars. So that's looking at just a single variable, right? What I said before was that it would be more interesting to look at maybe something like the meal price based off of the quality rating. So here we'd want 3 box plots next to each other in the same graph. So Excel allows us to do this quite easily. All we do is we select the 2 columns. The categorical column should be on the left hand side. The quantitative variable should be on the right hand side. And then if we go insert statistics chart and do box and whisker, and then let's do a quick layout and change it to this guy. All right, and then move it over here, make it a bit bigger, and let's add a chart title, and we're going to call this guy meal price in dollars by category. I don't remember what we called it. Let's see what we called it. Quality rating, by quality. So by quality rating. And notice that it gives us the good, the very good, and the excellent. All right. So looking at this, we can compare the meal prices based off of the quality rating for that restaurant. So what do you notice immediately? Well, hopefully you notice that as the quality goes up from good to very good to excellent, the average and the median meal prices go up, right? The maximum here is very good, the same as the excellent one, right? So you also notice that there's a very about the same kind of distance between meal prices. so about the same variation kind of in the middle 50%. It's a little different for this other stuff. So the good, right, it's right skewed, so is this one. Excellent is actually left skewed, so that's saying that you might be able to find an excellent restaurant for cheaper, right? It might be easier to do that than what we think. So again, box plots are good for looking at numerical quantitative data, and a lot of times we want to put it in a subset so that we can compare across the subsets within a single variable, which is what we did with the meal price inequality rating.